everyone. I'm Dr. Neha Patni. So today we'll discuss about some of the properties of lubricant. As in the last video, I already discussed what is a lubricant. So just to have a quick recap, any substance which is introduced in the machine in order to reduce the friction is known as lubricant. So today we'll discuss about some of the properties of a liquid lubricant. Let us discuss some of the properties of lubricating oil. Up till now you have seen properties of semi-solid grease, like the last video which I uploaded was based on drop point of the grease. So that was semi-solid. Now today we will see the properties of a liquid lubricant. Now if you say first of the property, it could be oiliness. Oiliness is nothing but stickiness. So it's just the ability of the lubricant to stick to the surface of the machine. So obviously in the machine, if it does not remain in the place, it may not serve the purpose properly. So what we want is, if any lubricant is to be used in the machine, it has to have a stickiness in it. So significance, you may say that it has to be high for a good lubricant. So now let us see the first property, that is viscosity. Now when a liquid is to be used as a lubricant, its viscosity is going to be very important. We should know what is the role of viscosity here. Now as you know that viscosity is nothing but internal friction of the liquid. So greater the viscosity, less ease would be there in the flow of a liquid. So we need to know whether the viscosity is too low, because if it is too low, the liquid may not remain in the position, right? And if it is very high, then the internal friction would be there. So we want to know that how much viscosity is there for a particular liquid lubricant. Now we have to calculate that viscosity in terms of viscosity index. Now viscosity index is nothing but a number, a rating which is given to a oil with respect to its quality. And here we have to focus on the change in viscosity with respect to temperature. So we all know that viscosity and temperature are indirectly related. Now if I increase the temperature, viscosity decreases. So I want to know what is the effect of this temperature on the viscosity of oil, so that whenever you are going to use that oil as a lubricant in the machine and then there is change in the temperature, what happens to the viscosity of lubricant, that is the concern. Now if you see that the variation of viscosity with temperature is very much high, means it is decreasing rapidly, so obviously the viscosity obviously is decreasing rapidly. That means the liquid becomes thin and it may not remain in the position. So we may say that the quality of oil is low. And if it is low, we'll call it as a low viscosity index oil. At the same time, if the viscosity is not changing much with respect to the temperature, means there is very slight change in the viscosity, you may call that the lubricant is of good quality, because the viscosity is not changing and the lubricant can serve its purpose. So you may say that the quality of oil is high, and at the same time we'll call it as a high viscosity index oil. Basically viscosity index is a number. So if I rate any, or if I give marks to any lubricant in between 0 to 100 scale, it would be like, if I give near 0, it would be low viscosity index oil, and if I give 100 on 100, it would be high viscosity index oil. So obviously our sample lies in between this range, 0 to 100. Now there are certain viscometers which you can use in order to find out the viscosity of oil. Generally they are redwood viscometer, saybolt viscometer and engler viscometer. And again in redwood viscometer you have two more, like redwood viscometer number 1 and number 2. Now what is the difference in these three is the amount of liquid you take while calculation. Like in redwood viscometer, it is only time taken by 50 ml of a lubricant to fall. At the same time in saybolt, it is time taken by 60 ml of the lubricant to fall, and in engler it is that of 100 ml, and it is also it also takes water as a reference with respect to oil. So 50 ml, 60 ml and 100 ml respectively. Now if you you see here, this is nothing but a redwood viscometer. The apparatus is redwood viscometer. The main parts are like this one is an oil cup wherein you have a oil level pointer. Till that pointer you have to fill the oil in this cup. Now at the bottom of the cup there is an orifice. That orifice is known as agate jet. So there is a hole present at the bottom of the container, and if you fill oil in it, you need to cover it so that the oil is not falling. So to cover it up, you need to use a metallic rod, and this metallic rod is known as valve rod. So valve rod is put in the place so that the lubricant is not falling. And just below that orifice, you need to put a flask in order to collect the lubricant if it falls. So you have to take a flask here. Now you have to actually the viscometer outside you have to fill water, because you are actually heating water and that heat goes inside. So we are not directly heating, so you just have to plug it and then the water gets heated due to this rod and the temperature rises inside. So here you have to take a thermometer also in order to note the temperature. Now this one is a stirrer handle, so you need to stir it like this continuously. You have to move this knob like this so that the water outside is moving. So if you move it like this, the water is going to move. So what that ensures is uniform heating throughout. So for that the reading and the experiment, you need to continuously stir it so that the heating becomes uniform. Now to take the first reading, what you have to do is you have to fill this oil in this cup till the pointer. Obviously put the valve rod at its place before doing that, and then fill the oil and then put a thermometer here. Now as soon as you saw that the thermometer is showing some temperature, let's say 40 degree. As soon as you get a 40 degree on thermometer, you just pull the valve rod. Now when you pull the valve rod, the hole is now open and the lubricant start falling down through this orifice. What you have to do is to note the time in seconds this lubricant is taking to fall. So the moment you get a mark filled up with the lubricant, the container will be like having around 50 ml, right? So as soon as you saw that the 50 ml mark has been reached, stop taking the time. So what you have to do is, as soon as you got a 40 degree temperature here, pull the valve rod, start the stopwatch and note the time in seconds it is taking to fall to complete that 50 ml. And as soon as it reaches 50 ml, put the valve rod back its place and stop the stopwatch and note the time. Now once again you refill the container, again start heating it. Now as soon as you reach to 50 degree in the thermometer, you again pull the valve rod, let the lubricant fall and note the time in seconds it is taking to fall. Remember, you have to take the readings for 50 ml only. So now as soon as you get that 50 ml mark filled by the lubricant, you just stop the stopwatch, note the time. Now you have to repeatedly do that because you want to know the viscosity with respect to the temperature change. So you have to at least take 4-5 temperatures and then 4-5 readings here. Now if you see here, these are the viscometers. As I said, there are two types of viscometer. So redwood viscometer number 1 and number 2, and they are different with respect to their diameter of the orifice. So remember, I said there is an orifice at the bottom of the container, that agate jet. So that diameter here is very less and here it is high. You may call it as a smaller mouth and you may call it as a larger mouth for the flask to receive. So obviously low viscous oil you have to take in this and high viscous oil you have to take in this. Say for example, if you are taking glycerine and if you don't take redwood viscometer number 2 and you take this much, the diameter is very less, so it will take time to fall. Similarly, if you take a thin oil in redwood viscometer number 2, so the diameter is much and it will immediately fall. Remember, we have to note the time in seconds it is taking to fall. So we have to select the viscometer judiciously based on the diameter and the viscosity of the oil.
In degrees. Then we have the stopper for the little hole at the bottom of the vessel holding the lubricant. We need to keep stirring the water of the water bath continuously to ensure the uniform distribution of heat. At the bottom, we have the measuring cylinder to collect predetermined equal quantities of the lubricant that flows through the orifice. The source of heat here is an electric heating coil and the temperature is controlled by this regulator. Let's begin with the first part. Filling in the glycerine into the vessel, we start the heating. The first reading will be taken at 40 degrees. It is important to stir the water while heating as mentioned before. As soon as the thermometer reads 40, the stopper should be taken out and simultaneously we need to start the stopwatch to measure the time it takes to fill the cylinder with 50 ml of the lubricant. Our first observation is 43 seconds. Refilling the vessel, we repeat this procedure for 50 degrees. Our second reading comes to be 27 seconds. At 60 degrees, the time taken by 50 ml lubricant is 15 seconds. Remember, it's important to keep stirring. When the temperature rises to 70 degrees, the stopwatch displays 11 seconds as the time taken. This brings us to our last reading. Heating the apparatus up to 80 degrees, the time taken by 50 ml of glycerine drops to 9 seconds. Moving on to the other viscometer, the redwood viscometer 1. As you will see, the apparatus is quite similar to redwood 2. But you'll notice that the orifice in this viscometer is smaller than redwood viscometer 2. This enables it to take more accurate readings of the lubricants having lesser viscosity. Moving on, you will see the same measuring cylinder and the temperature regulator as in the redwood 2. Beginning with the experiment, we will be using glycerine here. Keep in mind that continuous stirring is required for the uniform heat distribution, same as in the previous experiment. We start with heating the lubricant till 50 degrees. On reaching 50 degrees, we take out the stopper and measure the time for 50 ml to fill up. The first reading comes out to be around 45 seconds. Heating the lubricant till the thermometer says 60 degrees, we take another reading, 40 seconds this time. We repeat the procedure for 70 degrees and this time the glycerine takes 36 seconds to flow through the orifice. The last and final reading at 80 degrees gives us a time duration of 33 seconds.
Now you have seen the video that full video is already uploaded on my YouTube channel. I've just taken a trim video for you to see that how does a viscometer work. Now you have seen in the video that if you take the readings at different temperatures, you have to complete this table. So obviously we need to calculate the flow time in seconds. How much time did it take to fall at 40 degree, then at 50 degree, then at 60 degree. And obviously it is going to decrease, the time is going to decrease. It will take maximum time at 40 degree, and however when you increase the temperature, viscosity falls, so it will be easily flowing, and that is why this reading decreases. Now if you use this formula wherein A and B are the constants, and these constants vary with the viscometer you are using. So right now if you are using redwood viscometer number 2, you have to use A and B values accordingly. Then using this time and temperature values from the observation table, you may find the viscosity, and you just have to multiply kinematic with density to get that absolute, and density values are given here. Now once it is done, you will be done with your table. So you may easily plot the graph between viscosity versus temperature. Looking to the mode of the graph, if you draw that viscosity versus temperature, it will look like this, since the viscosity is going to vary much. Now as I told you earlier that there is low viscosity index oil, there is high viscosity index oil. You may see in the graph that this particular L sample, the viscosity is varying drastically with respect to the temperature. Now if you simply compare the viscosity at two temperatures, that's 100 degree Fahrenheit and 210 degree Fahrenheit, you'll be able to see that this sample has a drastic decrease in the viscosity. Obviously it is of very low quality oil, so you may term it as an L, viscosity index oil, low quality oil, and you will give it a 0. And at the same time, if you go for another sample which is showing you the best variation, like it is very less variation in viscosity, you will say that it is high viscosity index oil, it is a high quality oil, and you can mark 100 to it, give marks 100 to it. Now 0 to 100 you can give the two ranges. Now if you have to find out the viscosity index of a sample, you will take that sample and then you will find out the viscosity of the sample at 100 degree and 210 degree, and you may plot the graph. You will find that it is going to fall between 0 to 100. Basically, you have to use this formula. Viscosity index is equal to L minus U upon L minus H into 100, where L obviously is viscosity of low viscosity index oil, H is that high viscosity index oil, and U is nothing but your sample. Now, one thing to remember is the values which you are going to use would be at one temperature. See, if you have taken a sample oil and you calculated the viscosity of that sample oil at 100 degree and 210 degree using any viscometer, you'll be able to get this graph. Now, to select the L oil, you have to select the L oil from the list of L oils whose viscosity is almost similar at that of 210. Let's say the viscosity of sample at 210 is 46 seconds. So you have to select a low viscosity index oil which shows the same viscosity, 46 seconds at 210. That sample you have to take and you have to calculate the viscosity of that sample at 100 degree Fahrenheit. Similarly, from H viscosity index oil list, you have to select that oil to be taken as a reference. You have to select that oil which shows almost similar 46 seconds at 210, and then you calculate its value at 100 using viscometer. Plot the graph. So basically L and H you have to select based on it is going to show similar nature at one temperature. Then only you can compare your sample oil with L and H, right? So in order to compare it with L and H, you need to know first that they all are comparable, and for that the only criteria is that they show almost similar viscosity at one temperature. Now if you see one question here, the question says that you have to name the three viscometers. So obviously it is redwood, engler and saybolt. Now let's say that the oil has same redwood viscosity of 75 seconds at 210 as that of standard naphthenic and paraffinic oils. Their viscosities at 100 degree Fahrenheit are 462 seconds, 758 seconds and 452 respectively. Find the viscosity index of oil. And we have to comment on the quality of sample oil also. Now what are we doing here is we need to first find out the viscosity index of oil. For that the formula is viscosity index is equal to L minus U upon L minus H into 100. Now in the question we need to identify what is L, what is U and what is H. As I told you, L is low viscosity index oil. Low viscosity index oil means low quality oil. Low quality means variation is more. Now if you see these three readings and if you don't remember what is naphthenic and paraffinic oil, means which one is L, which one is H. Looking to the readings only you will be able to get. See, this oil is giving variation from 462 seconds to 75 seconds, from 100 degree to 210 degree. This oil is varying from 758 to 75 and here 452 to 75. Now obviously this 758 is showing greater variation, the most variation like from 758 to 75. So the viscosity is changing drastically here. So obviously this has to be a low quality oil. So we will call it as L, 758 seconds. Now out of 462 and 452, this 452 is showing better variation in comparison to this one. So you may call it as H because it's a high quality oil, 452. And in between you have your sample which is 462. Now if you calculate this, you'll be able to get this 96.7 answer. And since it does not have any unit, I told you that it is marks only in between 0 to 100. Now 96.7 is quite near to 100, right? So when you need to comment on the quality of sample, you can easily say that here it is a good quality oil. It could be a H quality oil because it's quite near to 100. I'll give you one more example, like if you can read these two questions as well, and if you can try to find out what is L, what is U here, you'll be able to get the following answers. Like just for example, if you see here also 320, 430, 260. And if you are going to compare, I think 430 is going to give you the maximum variation. So you may call it as L. This is going to give you least variation, so this would be H, and this is obviously going to be U. Now one point is there that you have to disclose which viscometer you are using. Like here it is engler viscometer, and here it is redwood viscometer, and like that, because that is going to tell you that how much ml you have taken. Like if it is engler, we said that 100 ml of the lubricant took 123 seconds at 210. Here if it is redwood, we'll say 50 ml of the lubricant took 75 seconds at 210. So that is one more observation. And now you can see the answers. I hope you are able to get these answers very nicely. So just to remind the fact that today we discussed two properties. One was oiliness, and we said it has to be high in the lubricant. And second was viscosity index, and that too has to be high. High the viscosity index of oil, less would be the variation of viscosity with respect to the temperature. Thank you.